Jamb 2026 candidates, welcome to today's lesson, and today we are looking at calculations under photoelectric using the Einstein's equation. All right, remember that Albert Einstein has two formulas that are very common in physics. He has one for photoelectric and he also has one for what? For light energy. All right, so please help yourself. If you need any help, you need any assistance, you are a last minute preparation candidate, send me a message on WhatsApp. Now my WhatsApp number be this, make I for help you, make you no waste this year again. Your friends go, they laugh you, your friends go leave you enter school, no waste this year. So enter DM, make I help you, make I send you materials. So if you say, if you all read, no, you don't see results. No, you don't see results, okay? All my reviews there online. Search my name for Google, you will see all my reviews there. Or search my name for AI. If AI you want search, you will see my reviews for them. No fail, no fail. You know if you get me, constant fail, send me message for WhatsApp. All right. The question we have in front of us here is Jamb must repeat question 1. Okay. Under the photoelectric, we are applying Einstein formula. Now the nature of the question now will make you know say na Einstein formula. We go apply this over. Okay. You get the way the question dey. Okay. But we go find the answer. All right. Gradually. I know say many scholars they don't already know the answer to the question already. But make we see whether the answer is the correct option you pick or the wrong one. If Einstein's photoelectric equation is represented by Hf minus W equal to what? This thing, okay? Where H is equal to Planck's constant, F is equal to frequency of incident radiation, and W equal to work function of material. What does this symbol, so this thing stands for? They say what this thing stands for, okay? And see all the options where they give us. They say A, energy of the photons, B, threshold frequency of the photons, C, velocity of the electrons, D, stopping potential of the photons, E, maximum kinetic energy of the ejected photons. This one are old Jamb question. Now make you go even they see option E here. This one should be Jamb question for 1990 something. Now it could be. All right. So first of all, they say make we find the value of this thing. Okay. Remember, say this Einstein formula. It gets two forms. We will learn it now. The Einstein formula. Okay. Einstein's photoelectric formula. Electric formula. The Einstein photoelectric formula or equation, we'll use equation. Now this, now I want to write so. HF is equal to, now this one is the standard one. They get two types, W plus KE max, subscript max. Alright, so now the equation be this. Alright, the standard one, okay. See the one where they give us for the equation. See here. HF equal to, okay, HF minus W equal to this one. Now this one they give us for the question. All right, they're going to say waiting be the value of this thing, waiting this thing represents. Then waiting they ask us. All right, so this formula here can be rewritten as this. We can rewrite it by bringing this kinetic energy, maximum kinetic energy to this side. Kinetic energy max, subscript mass, is equal to HF minus W. This is a way of rewriting it. Okay, we rewrite it this way. Okay, so HF minus W. So you already know what's going on here because we are going to use this to make comparison. Now compare, we will still compare. Okay, so the standard formula after making subject formula, we were left with this equal to, remember this one has mass. Okay, so maximum kinetic energy is equal to HF minus W. All right, so the one where they gave us HF, okay, minus W equal to this. You can now see some similarities between the two equations. Okay, so like I said before, this HF, okay, stands for here. This HF here, it stands for the energy of incident photon. Then what again? W next, right? W stands for what? Work function. And what is work function? Work function is also, or is defined as the minimum energy needed or required. The minimum energy required to eject electron. Eject or to remove electron. Okay, that's this work function. That's the definition of work function. All right. Then this KE maximum. It's already easy. Yeah? This is the what? The maximum kinetic energy of ejected photon. All right, the maximum kinetic energy. Okay, energy. The maximum energy we carry. Okay, that's that for that. All right. So with all this, remember they tell us make we find the value of this thing. Question mark. Now this thing they say make we find the value of this thing. Then carry us come here. So I just want you to understand this formula. Okay, so like I said before, we were given this one, and this one is the standard. Okay, so we have to compare it. We have to compare both. Okay, so here now, W cancel W, they be the same thing. HF cancel HF because they be the same thing. So we are left with what? KE max and this thing. So what you mean I say this thing and KE max not the same. Alright, so what you mean I say this thing now KE max. So what is KE max? Maximum kinetic energy. So KE max means what? Maximum kinetic energy. Kinetic energy of ejected what? Ejected electron. Okay, maximum kinetic energy of ejected electron. So that's what this also stands for. This one. So with what we have just understood, among the options, pick the correct option and drop it in the comment section. The value of this thing. Still under Einstein photoelectric, question 2. Let's look at the question we have here. Jamb must repeat question 2. The work function of a metal is 3.5 times 10 raised to the power minus 19 joules. If Planck's constant is 6.6 times 10 raised to the power minus 34 joules second, calculate the threshold frequency of the metal. Threshold frequency of the metal. All options represented in what standard form and in what units? Hertz, which is what? Frequency. Okay, the units of frequency. All right, since they said we should calculate what? Calculate the threshold frequency. All right, we are going to apply the what? The Einstein formula of photoelectric, where W is equal to HF naught. Okay, W is equal to what? HF naught. This W is work function. Okay, and work function is the minimum energy required to what? To eject photon. And we have H here and we have F here. What does H and F stand for? H and F is a mixture or is a combination of two parameters. One is frequency and the other one is Planck constant. Only this H here that you see stands for Planck constant. This other F we have here is what? Threshold frequency. All right. So we have to, since we are looking for this threshold frequency, we have to rewrite. But first of all, let me just write it out for you. Okay. W is equal to what? Work function. Work function. Okay. Work function. And you know the definition of work function. And your work function must be in what? Joule. If you know the joule, if you did kilojoule, convert them to joule. Okay, then your H stands for what? H is Planck's constant. Planck's constant. Okay, they gave us here. This is Planck constant. Planck constant. Okay, Planck's constant. And Planck's constant is usually in what? It's usually in joule second. Okay, joule second. Okay, they gave us. Okay, and FO, which is what? F naught, which is what? Threshold frequency. All right, equal to threshold what? Threshold frequency. All right, so we now know what all this stands for. All right, now let's write out what we were given for exam condition. No be so you go dey slow dey solve am because I dey teach you this thing. If I want solve, this thing no go take me reach 15 seconds to solve. If I want solve am, I no go even write many things like all this giving. I just want you to master the act of solving before you start to do fast solving. Okay, so for exam condition, you just have to be fast. All these things wey dey waste time, no need to do them. If na exam condition I dey now, all these things dey inside my head, no need to write them out. You understand? So this one, since we don't already see, and as you write the formula now, if in exam condition, as you write the formula now, all you have to do is to just make what you are looking for the subject of the formula. No need to be writing out giving. Okay, just the write them inside as you just look at. They gave us Planck constant here, put them inside the formula. They gave us what you put them solve and get your answer. You come up for the sharp. All right. So they gave us what? Work function 3.5 times 10 raised to the power 19 joule. Okay, work function equal to what? 3.5 times 10 raised to the power minus 19 joules. All right. They also gave us what? Threshold frequency. Now we define F. Yeah. Then they're going to give us with Planck's constant, which is H, 6.6 times 10 raised to the power 30 minus 34 joule second. Okay, minus 34 joule second. All right, now this one they give us, make we take solve. All right, so this is the formula for threshold frequency. We get H here, C and here. We get W here, C and here, work function. So we can solve easily. And all of them are represented in the unit that it's supposed to be. Okay, I will say this one now dey for kilojoule. Now we will need to convert them to joule so that we will get our answer. Or if you use and solve finish your answer, you can convert your answer to joule. You understand? So that maybe you forget the correct answer. All right. So since this threshold frequency there, we'll make threshold frequency the subject of the formula, and you know the mass now. We're gonna get something like if we bring and come down F threshold frequency, this one will come carry and go up. This H will come be denominator. You understand? So it will be equal to W over H. So if we substitute into the formula, we are going to have what is work function. See our work function here, 3.5 times 10 raised to the power minus 19 over waiting. Our Planck constant will be 6.6 times 10 raised to the power minus 34. Okay, you see them? So we go do this raised in power separate. We'll apply the law of indices for here since they get the same base. You understand? You know how they go now. So if we do 3.5 divided by 6.6, we'll get that one will give us we'll put on here, it will give us 0.53. Now, waiting calculator talk times. How I want to do the 10 raised in power? Put brackets here for the raised in power. Okay. Remember, when you get over for indices, over will come turn to waiting minus, or divide will come turn to waiting minus, since you take the same base. Okay, so we're going to get something like minus 19, bracket close, minus, now minus 1, you stay sub there, bracket open, minus 34. You see, bracket close. So if we solve this thing now, waiting we go get, okay, minus 19 minus 34. We're going to do direct minus, we're going to do direct 19 minus 34. That one will give us 15. Now 15 it will give us now 15. So we get minus for here. It will come carry this big one home. Okay, it will come be minus 15 because the bigger one they carry minus. All right. So we are now going to be left with what? 10 raised to power minus, it's equal to minus 15. I put down here. Okay. So it will come be equal to 10 raised to power minus 15. All right. So since we get this thing, if we want to convert this thing, this one want convert this standard from here. This figure will get your one convert to two significant figure. What we will do if we want to convert to two significant figure? We're going to shift this point. So this point will carry this 0, minus this 0 for here, then shift and come here. Point will come here. Then this 0 will go minus and from here. You understand? If we put points for here now, this 0 will need to minus and from this 15. It will come be raised to power 14. So we're going to get something like 1 minus 15. Okay, it will come be equal to 14. This 1 0 here will minus and from 15. So 1 minus 15. Can get 14. So now 14 will come there. So what we will come get here will come be 5.3 times 10 raised to power 14. Okay. So now this one will be the answer. This answer, they try to make them fit waiting we get among the option, because we don't get any option we get 0 point something. So we need to convert them. Okay, to suit. Now they always talk and say if you don't solve finish, look your option. Okay, maybe they sure. So this one will be the answer. So among the option, pick the correct option, drop it for the comment section. Now they sure say you understand what I just teach. Before I go, I will leave you with this small information about this topic, because this one is our last question for this topic. Okay, note something very important. Note that kinetic energy, maximum kinetic energy, is equal to, okay, and this Vs is what? This one is stopping potential. This one, so Vs is stopping potential. Okay, whereby Vs is equal to stopping potential. So maybe they say make you find maximum kinetic energy and they give you stopping potential. You all know say now this one, now this one be the answer. Just pick this one as the answer. All right? Or maybe they say make you solve for make you use that other Planck constant formula. That formula where you get something like H F minus W equal to this thing. You know, say this one stands for maximum kinetic energy. Okay? Maybe for example now they can't go give you this thing. Now they give you for the question stopping potential. They can't tell you say make you find this one work function. You can't make work function the subject of the formula. How you go can't take get this one? So this maximum kinetic energy. How you take get that? How? You just use your weighting. Since this one they equal to this one, you use your weighting, your stopping potential, get your answer. Okay? And one E stopping potential is equivalent to 1.6 times 10 raised to power minus 19 joules. So one of these thing is equal to this. Maybe the equivalence. Okay? That's that for that. See you in the next class.